Thank you, Newton, for coming on and letting me host you here and ask you a couple of questions and learn more about your background and how you got into engineering and your whole journey and everything with graduate school and fundamentals exam preparation and all of your work with Legendfortutoring and starting that company. I just want to start out with saying hi, thank you, and will you please give us an introduction?
Well, thank you so much, Kelsey. I definitely appreciate your time and dedication. So again, I'm Nabil, go by Newton Khatib. I do have an undergrad and master in civil engineering from University of Colorado, Denver. There's one banner here, right here, but I replace it with, Legendfortutoring. That I'm also affiliate professor at CU Denver and Metro State University. Also a practical bridge engineer in a consultant company, and proud owner, or one of the owners, of Legendfortutoring. So that's pretty much me.
Nice. So I know you didn't start, or I know you weren't born here in the United States, and so you moved here from Jordan. So can you tell us some about how life was out there, how you got into engineering there, and then your decision of transitioning and coming out to the States to study engineering?
Well, yeah, I grew up in Amman, in a kind of like comparing to the U.S. is very small, teeny tiny country, about 11, 12 million populations, and Dad, obviously he has better vision than me at this point, and way before I came here, he thought that I could be something. I don't know if that's really going to happen or no, but he thought that bringing me here and kind of like study engineering or medicine in the medical school. I did I still love math, but when I was in my high school, I really wanted to be a professor in the math department. He had a different kind of opinion. He said, you kill two birds in one stone with doing engineering. So try it if you think that you like it. And probably a lot of us kind of like start that way. They're good at physics, they're good at math or something, and then you kind of develop that sort of skills. So I came here back in 2012, so about like 9-10 years. And I started engineering. I picked civil engineering just because I really thought, and I still think, that civil engineering, structural engineering is pretty cool. You see buildings, you see bridges, you see all the infrastructures. And I said, why not? Let's just try it and see if it's gonna go well. And actually, a matter of fact, is kind of like, this is just math. I'm doing math, right? Like statics. And Kelsey, you definitely know, and you're on board with that because you're also an engineer. And like you do like the statics, the mechanics of materials, all the drive courses, the core courses, and you feel like, it's just math. That's for me to do engineering. And at the end of the day, I'm going to be called an engineer with all these math courses. So that's kind of like where things shifted after one of the senior courses, reinforced concrete. I was like, okay, so we're using this to do this. We're using all these equations, quadratic equations, solving all these, fun, kind of like sharpen your pencil and doing all the derivation. And then at the end of the day, you're like, well, you need AS equal 5.1 inches squared. You probably make an assumption like why I'm learning all the calculus part, all that thing. That kind of like a quick story about me. But regarding the transition, was obviously tough. Speaking Arabic, never spoken English before I came here. Dual citizenship, my friend used to make fun of me. I was like, you're just American, and citizen, but you can't speak English. So it was really funny. Came here, I was like, well, I need to communicate. I need to explore the world. I need to make sure that I just kind of like at least the basic things that I need, go to a shopping center or go to a grocery store or something. So it was very, very tough. I took the light rail for the first probably 3-4 years of probably all of my undergrad, even some of the grad. And I learned a lot on light rail. People talk, but you could notice right away when you talk, people look at you as like, this guy has an accent. So that's,
So I have a question about that because I had a lot of international students that English wasn't their first language when I was a professor at Embry-Riddle, and I taught a programming course. So I always thought I couldn't imagine that transition of sitting there, we're writing code all in English, but I was always curious, like, how was that in your math classes or any, like your statics classes, physics classes? Did you ever find that the language was a barrier or difficult when you're transitioning, like, because you learned all your math in Arabic and then all of a sudden you have to have a background and they're talking about from an English language.
Yep.
Was that ever tricky, or how did you navigate that?
It was definitely tricky. It was very tough.
Yeah.
I mean, as I was talking to one of my, friends, learning English is different than learning math.
Mm-hmm.
And learning math is different than learning English because you probably could be a good, student, but the language barrier can definitely back you off or back you to get your kind of like full understanding.
Mm-hmm.
So for example, and I still, kind of face these issues when you read a problem, and obviously that's not for native or native. When you read a problem or you read a statement and you understand 80% versus you understand it 100% is totally different.
Yes.
You go like say, well, what is this? What is this boom? What is this dozer? What is this, thing? It's like, well, I kind of generally know what the problem is trying to tell me, but I do not fully understand it, if that makes sense.
Yes, like the context was a challenge.
Exactly. So when you learn, let's say the derivative or integration or all these parts, but then when you get a question is, wants you to do like one piece of information that you really know, but it's wordy. You like read the problem and say, well, tell me what a problem needs to be taken care of, and I will do it. But since you're really like not fully understanding the problem, or it's a worded problem, that's not native versus non-native. But for non-native, obviously, it's going to be even harder.
Was there ever times that you felt like you could talk to professors you had when you had those problems of like you didn't understand the context, and like how would you approach the professor and what kind of conversations and what did they do that helped you the most? Or like,
that's actually a great question, Kelsey. Some of the people or some of the professors that I faced, they don't really care, but some they do care and they're really responsive and kind of try to replace one of the words that is in the problem statement with the easier word. I don't know, maybe like if you think, I can't think of a word like in engineering, but think about it in like and just like slang, gregarious versus friendly. Have these type of things, and like they replace the word as like, does that make more sense to you what the problem is asking for? Some of them they're like, I don't care. You want to Google the meaning in Arabic and just solve it? I have no problem. Some people, some professors like, nope, I'm not going to treat you differently. So
like in the sense of like, I'm not going to acknowledge the fact that you would need additional help because you come from a different background.
Yes. And that's not really fair.
No.
Because you can't like treat me as someone who grew up speaking English. I get it. It's not your fault.
Right.
It's my fault because I came here and I need to do all, the hard work. But
right. But I mean, there needs to be some acknowledgement of, okay, different people from different backgrounds need different kind of help, but like not really help, but like scaffolding, like the idea of, okay, I'm realizing and acknowledging that my problem, oops, sorry. I'm realizing and acknowledging that my problems are very US centric, and like, okay, how can I make sure that it allows other people from different populations to be able to identify with the problem? And if you can't do that, then at least like take the time to sit down and try to provide different context. I think that's important. That's a good. So yeah.
You know, the best thing to do, to be honest with, in my opinion, is do not let him or let her use the smartphone to translate it. What Dr. Brian Brady did really great job, I think. He tried, you know, to replace one of the words or kind of explain the questions to you as like a quick sketch or a figure that, you know, illustrates what's going on. Okay, here's the boom, here's this machine, here's a dozer is trying to do this. You're trying to find the moment right there. So treat this as, you know, it doesn't have to be really in depth, but it could be a big picture, right?
So it sounds like to me like the advice for professors would be to really like be willing to take the extra time and try to swap out words and try to draw figures when possible, sketch it out, and just really paint the picture, make the context more clear. That way, when it comes to like really assessing the math component and like, can you do the engineering side, you're not limiting someone because they don't understand the problem or the context provided.
Exactly.
And then from a student perspective, I think you kind of hit at it, but I'm kind of curious. So if a student is a non-native English speaker, would you tell them to stop using the Google translations and translating everything to their native language? And like, why? What do you see the benefits of that? Because I've seen a lot of my students doing that.
Well, to be honest, we had a conversation, me and one of the guys who work for Legend yesterday. He's also about to get his PhD in geotech. And it was not exactly about what we're talking about, but it was very similar to what we're talking about. He mentioned, you know, I want to move to Colorado. Do you think there is a big Arab community here? Because he cares about the community more than other things. And I totally understand you. So I was like, why? And he said, because, you know, you want to like go and have fun and, you know, do all these things. And like with some people that they know your culture previously and they don't have any trouble understanding you. So I was talking to him. I said, well, one thing that you want to do if you really want to be a better version of yourself is you want to always take yourself from the comfy zone. Just put yourself in discomfort zone and make sure that you learn other people's perspective. It's not about like engineering. It's not about religion. It's not about anything. It's more of like, can you communicate with people in their language where you really live in their country? If you could do that, you could obviously have some time for your, you know, community. I'm not saying that leave your community, you know, period. That's absolutely not. Or forget your language. No, you know, Manal, she knows how good I am, or in Arabic. I'm very, you know, in depth in, you know, I love Arabic. I love to get into the nitty-gritty things, but also you want to make sure that you merge and you're kind of like dissolve in the community to be part of them. And then once people, and I was talking to him, I was like, do you see what, you know, other people talking about our culture, our religion, our, you know, so on and so forth? I said, because we did not do a good job to present ourselves. So present yourself and your neighbor, you know, with your neighbors, with your colleagues, with your friends, with your folks, with your, you know, anyone who, you know, communicate with you, or people can like have a day in, day out, probably connections with you. Do not leave. But speaking of Google and translating, when I came here, I started translate every single language. Which makes sense, right? Because, you know, I don't understand what the question is asking, especially some, you know, upper level environmental courses or something. I was like,
Yeah.
What if it's in Arabic, you know?
Mhm.
But I learned something. Doing this, it kind of detach you from to learn it fully, if that makes sense, to grasp the knowledge. Like, okay, you're saying integrate this. You don't know what is integrand mean. Okay, so if you translate integrand and you keep saying that in Arabic, for example, or either language, when someone will tell you, hey, do you see this integrand? Take it out and replace it with something else. You'll say, what is the integrand? Because you just keep translating this. Like for me, I always, or I used to translate pretty much every single word in the problem. Copy it if it's a electronic version, paste it, put it in Google, read it in Arabic, and then I was like, okay, I know how to solve it.
Mm-hmm.
Right? So it detaches you from the full benefit.
Mm-hmm.
Full benefit is not math only. The full benefit is to, can you use these terminologies and nomenclatures in your context when you talk to people? When you start explaining things to people, can you say, well, a moment, torque, torsion, couple, all these pretty much the same, as you know. You obviously can't teach me this. So.
So, yeah, that's really interesting. Okay, so this is like a major tangent, somewhat. I didn't plan on asking this, but based on what you were saying, I know from my experience of like being a woman, and I've talked about it sometimes, like, and not being as represented in engineering as like, as I am in like the normal day-to-day population. And so sometimes I get this, like, I've seen it in research called stereotype threat, where it's like I have this idea of like I need to come in and represent for all women, and so I have to do like even better because I'm representing for women. And like sometimes that gives me extra anxiety on tests or on different things. And I know you said something about being a representation. Do you ever feel that? Did you ever feel it, or do you ever feel it now of like that extra? And again, I think sometimes it can be a positive of like that extra push to do better, work harder. But do you ever feel it on the side of like a stress as well, or how is that affecting?
One of my professors, he was very shocked, sadly, when I told him that I'm Middle Eastern. He was like, he looked at me, I was like, really? You're so smart. You're so, like, in that way.
What does that mean?
Exactly. And I was like, well, let me tell you something. We are, very clever and smart, but sadly, people come here to take advantage of certain things and do not focus on other things. So you can't always, do a prejudgment type of thing.
Yes.
Right? He's a great guy, I really love him so much. And it was funny the way he said it because he's like, I found out that you're Middle Eastern. Is that right? I was like, yeah. I was like, wow, that's just shocking because you just so hard worker and smart. And I was like, well,
Oh my God.
because he saw that other people, and I was talking to the same guy yesterday. I was like, when we do something crazy as a community, it reflects on other people. Say, well, he smokes, at the entrance. He yells, at his friends and not paying attention to other, people in the public. These things is going to reflect on right away people when they look at it and say, Middle Eastern, do this. They go to hookah bar all the time and they do. That's what it kind of obviously I kind of like off of a tangent, but it's kind of like sort of helping me to illustrate what I'm trying to say with push yourself.
Mm-hmm.
Always prove to yourself first and prove to others that you can do it,
Mm-hmm.
not because your ethnicity, It's just because some people are good, some people are not as good as others. And I did not want to say bad because I know that everyone has something good, but you want to discover that thing and you want to say, okay, where are my strengths? Where are my weaknesses? And that's something that people like, oh, I have this, strength. I'm gonna just leave it right now and work on my weaknesses. No, that's not true. Work on your strength as you work on your weaknesses, because your strength becomes to you intuitive at some point.
Yeah.
It's like boom, done on the spot.
Yeah.
Right.
Yes.
So
Definitely.
again, I don't want to obviously branch so many things here, but I want to make sure that people, when they go in, learn a different language or learn a different subject, try to give yourself a push by X reason. Like, for example, for me, if I wake up in the morning, I get my coffee, get Snickers, dark chocolate, these type of things, it, pumps me. Draw a sketch, draw something on your, on your piece of paper before you go to bed, and kind of like, this is what I'm gonna do tomorrow, and kind of like, do not break promises with yourself. If you break promises with yourself, soon enough you're gonna break promises with other people.
Yes, that's good. So, I mean, that brings me to another point. I know you do a lot of motivational speaking. Would that be one of your biggest points that you like to highlight and emphasize? Or is there another one, like something that you try to focus on with people, like when they're, finding that motivation within? Or
that's actually one of the kind of the things or the keywords or the keynote that I typically give to people. But it depends, Kelsey, from let's say 17 years old versus someone who's in the 30s or 40s. When you talk to someone who's, one of my close friend, he's 30s and he doesn't have that motivation because he's, not smart or something, that he's like, you just every day is the same routine, all that. So he's like sick of what he's doing, not because he's not good at what he's doing. He's pretty good. He's very sharp, but he's also saying, well, I did that yesterday. I'm gonna do that tomorrow, and so on and so forth. So, find the sweet spot for you. Maybe a walk, 10, 15 minutes in the morning. That's what I typically like to do. Like, for example, for me, I wake up 6:30, max 7 o'clock every day. Like to get my coffee first thing or water first. I'll probably a liter of water before I do anything. Some honey, and then coffee, chocolate, dark or whatever, Snickers or any, bar of chocolate. And then maybe if the weather permits, Colorado's crazy. So I'll go on. I'll go on a walk for 10, 15, 20 minutes, maybe run for 5 minutes, and then walk for 10, and then get back here very fresh, take a quick shower, and then you start working. Have that piece of paper on your plate, and you look at it and say, okay, I'm going to do 1, 2, 3. Prioritize yourself. These things is different than other people 16, 17, 18, because I've been recently involved in so many of those, kind of ages that people like, well, I'm smart, I know myself, but I don't want to study. That's a totally different, animal, right?
Yeah. What do you say to that?
Well, you kind of like with these people, you want to, it's kind of same philosophy, but you want to say, hey, I'm going to challenge you. These type of ages love challenges. If you do this, I'm going to send you a gift card. Like literally, I have, my clients, if I show you how many, gift cards I sent this month or last month, probably more than 10, 12.
Wow.
Even if it's like $10 or $15 or $25. It's got, oh, if I got 90s, I'm going to get a gift card. So I'm going to buy makeup. Yeah.
Yeah.
Oh, this or buy that. And she's like 16 or 17 or 14 or 15,
Uh-huh.
that that's going to make her or make him obviously different, things will make people kind of like boosted. Oh,
Hmm.
this. It's going to be only 1 week. I'm going to study hard. I'm going to get their word. And I'll
Yeah.
coordinate with the parents with the same philosophy.
Hmm.
All go, obviously as planned. But if you say, no, you have to think about your future, she's not going to think about the future. He's not going to think about the future now. You want to give him an instantaneous, just feed him
Yeah.
right away or, feed her right away because they're not going to have that mindset and mentality where like, I'm going to be a doctor. I'm going to make money. I'm going to buy a house, buy a nice fancy car. They're not going to have this mentality. So you
Hmm.
want to hit kind of like the right angle as engineers, we know like whatever, 45 degrees or whatever the type of angle that you want to hit and kind of
Yeah.
accomplish the goal.
Yeah.
So,
Nice. All right. So going back, so continuing back, you did your undergrad. We talked about that some, and then you went on to graduate school. And so I would love to know more about that transition, like that decision. Why did you decide graduate school? Were there internships along the way that like influenced that decision, or research positions or teaching positions or anything like that?
well, to be honest, it was no internship in the
Okay.
it was merely a passion that I really wanted to be a professor since probably 16, 17 years. Um,
Wow.
yeah, I used to go with my sister to one of the university back in Jordan. And when I look at the professor, they're lecturing, I was like, that's really cool. You see people listening to them and kind of like
Yeah.
all the attention they need to please them. And obviously now, my mentality has changed and this 16, 17, I care about, showing off at that point.
Yeah.
It's totally different. But I really fell in love with that kind of like atmosphere going, and you're kind of like, especially if you get a good job, or kind of like on your own, you don't have to obey all the rules. So I thought flexibility, agility type of thing is kind of like cool. And obviously, this is you're talking about someone who's like 15, 16, 17, so doesn't have a lot of maturities. Even though it has a lot of potentials, but it's
Mhm.
still thinking about PhD or being a professor as just
Yeah.
going to teach people. It's absolutely not that way, especially if you want to go with the research.
Right. There's a lot more to it. Yeah.
So when I came here, one of my professors, Dr. Kim, offered me a scholarship for my master
Oh,
study. So I was like, he was into concrete and he's still into concrete, and I was like, well, maybe we could do this, and you don't have to pay for your graduate studies, and you'll do teaching assistant with me and research assistant with me. So
mhm.
I kind of like liked it for so many reasons, like kind of
Mhm.
like pay off my school or have to have a debt, any loans going on. I also love teaching, so kind of like also touched me on that spot and kind of like, oh, okay, it's really cool. And then research, I was like, I'm not a really huge fan of research, but still like new things that I want to learn to kind of boosted my energy as well. I was like, let's do it. So that was one of the reasons for continuing. Or actually, if you want to summarize it, just like being a professor, I was like, I want to get to the top to be a professor. I
Yeah.
love teaching. I love helping people. I like,
Yeah.
especially simplify all of these, big concepts to kind of like discretize them and kind of like
Mhm.
give them to people in a simplest or in the very understanding way.
Yeah.
That
Absolutely. And so then you completed your master's, correct? And then now you're in your PhD. Where are you in your PhD process right now?
well, I've done my courses,
Yes.
but I'm a slacker. yeah, done with the research or with a dissertation. I'm hoping, to be honest, every time I talk about the PhD, people are like, you're gonna probably in 2 years say, I'm hoping to finish it in 2 years, because now you're involved in other things. Before the legend, oh, I'm gonna focus on the PhD, get it done, and just be a full-time professor. But then the legend came. I was like, you know what? Let's give it another couple of years, and you probably do another kind of like sort of chit chat with me in 2 years. It's like, no, are you about to be done? No, there's something going on right now.
Something else.
Exactly.
So then you're done with your courses, you're done with your preliminary exams, I would imagine.
Yep.
And then you're done with your proposal? Or
I'm done with the proposal, I would say partially, but not really.
okay. Because then you get that. I remember when I finished my proposal and I was like, I'm a PhD because you're a candidate, And then I was like, I want to just put PhD on everything. I had put in my email signature for a little while and people were like, nobody does that. And I was like, well, I'm excited. But yeah. And then the dissertation.
Yep.
Oh.
that thing is definitely a beast. I'm like,
so where are you at in deciding your research topic? Or your research questions?
No, I think that's probably 20%.
Okay.
25 max. I mean, I know what I will be doing, and hopefully which is bridges and kind of like evaluation inspections.
Yeah.
Kind of like mainly concrete bridges, and finding like deflection for corrugated metal, steel, culvert, especially in Colorado Springs. There's a lot of those. So I was involved in my master, thesis on that thing. And I kind of liked it, but then I went to practice. I was like, you take another aspect of the design aspect. And then you're like, okay, so what all the researchers, kind of like do, they put it in certain format or simplify in a certain equations, and the designers that really don't care about all the research. They just like the summary or the final formula and say, okay, we don't really care what exactly going on. We're gonna take this. So I'm hoping to go back, soon, hopefully, and then continue with that and get it done in a couple of years. But you never know, Kelsey, right?
Right. I know. It's always interesting to me, like how that timeline works out when people are like, okay, I'm going to get my PhD, like, and how long does it take to get a PhD? And I'm like, well, that depends. Like, one, do you have a master's? Okay, are you including the master's as part of how long in your graduate school time? Do you have a bachelor's? Like, are you including how long in that? Because it's like bachelor's, that's pretty commonly 4 or 5 years for engineering. Master's, that's pretty commonly 2 years. Sometimes like 2 to 3, I would say. I would say a lot of times 2 is what I hear. Unless you do like the master's +1, where they do that 5-year program, which is just.
I actually did it in 1 year.
Wow.
But, yeah, I did like exactly 11 months.
Wow.
Started in fall, spring. Yeah, spring and fall.
Wow. Was it a non-thesis master's then, or?
It was a thesis, but I started the thesis when I was undergrad.
When you were in your undergrad. Okay. So then you were kind of like the 4+1 type plan. Yeah. Okay. Yeah. And so then it's like that timeline, and then, but PhD, it's always, I mean, like the courses is such a small part of it. A lot of it is just really that research that you're like, oh my goodness.
And like for Boulder, they want you to publish at least 3 to 4 papers in obviously a well-known, journals. And you're like, well, you still need to wait for people to approve your, this better than me. Obviously, you could obviously share with me and with everyone.
Well, I can tell you that right now I have a paper that we submitted to a journal. God, when did we submit that thing? well, it takes forever to get the writing. It takes forever to get everyone on the team on board with like the final edits. You would like, you get to a point where you're like, okay, I think I'm done. We're on a paper right now. We met today and we're all kind of at the point where we're like pretty close to done, but we've been pretty close to done with this one particular paper for like 6 months. And then we still haven't submitted it. So then we still have to submit, but another paper that we have already submitted for a journal, we submitted it back in August, I think. And this has actually been a very quick turnaround. They gave us feedback, I think January-ish. And then we turned that thing around right away. That's quick. Oh my God, that's quick. And then we turned it around like real quick. And then they actually, it's only been under the second round of review for a month. And it's still, we haven't gotten notice yet, but it said it went from under review to finalizing review or something like that. They're going to give us a notice soon. So that's only like a month turnaround, which is super exciting. Yeah. Oh, that's fast.
Wow.
That's super fast, like crazy fast. To get a paper published for a journal within a year of like your first submission, that's super fast. And like from my experience and what I've seen with others, because like, again, the higher tier you go to and like the more that higher impact factor that journal has, the longer it's probably going to take. So I remember one of the papers that I was a second co-author on that was in Journal of Engineering Education. We submitted it when I was in my second year of graduate school. So that would have been 2012. And it went through the review. We had major revisions, like minor revisions. We restructured the paper. So we resubmitted it as a new one, even though it was the same paper, So 2012. And then we had the paper published in 2016 or 17, because it was in my first year as a faculty member, which benefited me because then when I was a faculty member, I could put Embry-Riddle in my professorship position and it counted towards my tenure then. Because anything you do in grad school doesn't count towards your tenure because it's the wrong university on the label. So that was helpful, but that's 4 years for one journal paper. And then the other thing is like, you have to think about that data, and your results. So if like all this data and results, oh my God, I could go on forever. But anyway, like your data and your results is so dated by then that you're like, okay, it's a year, 2 years, 3 years, 4 years at times, versus like a conference paper that a lot of times will be quick, but then every different discipline seems to be different when it comes to conference papers. So like I did a faculty search with computer science, and my understanding is their conference papers are similar to how they are in engineering education research, where you have to submit a full paper, like you submit your paper. Well, first you submit an abstract, so like a proposal for your paper. They approve it or they reject it. If you're approved, you submit your paper, and then they approve or reject your paper, or they tell you to revise it. And then you revise it, and then they approve or reject it. And you do that in the span of, like, I just finished a conference paper that was approved abstract and then approved first draft, which is always the best because then you're like, oh, I don't have to wait for that approval or rejection on the second round. Like if they approve you out the door, but you're like, you got to really put in that time to make sure it's all in place. But anyway, so then you have like a full publication. But I don't know how it is for civil engineering. I know some disciplines of engineering for the conference papers, like they don't review the conference paper, so they don't count it as a publication.
That's
so like when you,
That's what I think.
Civil is that way, I think.
I think civil's
Yeah.
bolder that do not count as a published paper.
Correct. And that's because a lot of times for those conferences, my understanding is you write up like 2 pages, maybe like, and it's just to go, it's more about the presentation than it is about what you wrote. And they don't necessarily publish it because it doesn't go through that round of blind review, whatever that review looks like.
But it still looks really good on your resume.
Yes, it still looks good, but it doesn't count as a publication. Versus like when you have a conference that they do the like blind review process, then those ones, they do count as a publication. sometimes, but it's hard because like since engineering, we have different background, like each discipline has a different way of handling conferences. It's always important that like if you are one of those disciplines that you do have to go through a blind review process for your conferences, that you communicate that, like especially going up for tenure, you have to be like ahead of time say like, hey, I want you to understand like ours are full papers. Like my conference paper that was just approved is 12 pages, not including citations. It's a full paper. You know, it's not like just some abstract.
1 or 2 pages. That's a full paper.
Yeah.
Wow.
Mm-hmm.
Are you, out of curiosity, what type of like research that you're doing right now? If you can share.
Right. Yeah. So right now, all of those are, so I received a National Science Foundation grant back when I was at Embry-Riddle, and I finished it up when I was leaving Embry-Riddle, but I still am continuing to finishing publications because as you can imagine, if it takes a year or 2 years to get papers out the door or more, then it's like that work continues. So we still meet once a week, and we're like, right now, like I said, we have that journal paper under review. We have a journal paper that we're finalizing. We have a conference paper that's approved and we're finalizing, like we're still going through and like editing it, cleaning it up. And then we have another paper that we're debating, and it's all on modeling in engineering. So our context is all first year engineering. So when first year engineering students come in to engineering, like they don't have a strong foundation in like mathematical models, CAD models, and all these different types of models. And a lot of times they're only aware of like physical models, like prototypes, because that's what most kids see when they're younger. Like they'll do scaling and like those little car models, plane models, something like that. A lot of people have interacted with those, but not necessarily anything else. And if they have, they haven't really had labels to it. So like when they're in math class and chemistry and physics, like I don't think a lot of those high school teachers are saying like, you're developing a mathematical model and like now we're going to put it into a computer system and that's a computational model. Like I don't think they're really using that language, and we can't expect that. But like as engineering professors, you know, like those engineering professors out there can acknowledge that and watch for that, and then try to help students raise their awareness of these different types of models. Because then even in undergrad, a lot of times that gets like glossed over. So like you're in a statics class and a physics class and dynamics, and like you're you know, you have this big long word problem and you have to pull all these different equations to solve that problem. But nobody's telling you, hey, what you're doing right now is you're developing a mathematical model. And then nobody's telling you, hey, you can put this in a software and now you have a computational model. Or, hey, like if you draw this up in CAD, like you have a CAD model. Or, hey, if you sketch it out on paper, you have an engineering design. And like that's that important aspect of like developing that language. So then you're aware of like modeling. And then also like, you know, that's that first foundation. When we're learning, first we have to just be like aware of what it is, defining it, and then really understanding, okay, what does that definition mean? And then like the application component, which is so critical in engineering. And like we need to know how to apply, build different models. So that's what a lot of my research is around.
That's really cool, because kind of like when you develop multiple of the equations, combine them together, that would be a mathematical model. And then once you put it in software, that's more of like a software model.
Yeah.
I've never, you know, thought about it that way, because sometimes I derive multiple equations and I can make a simplified version of a huge equation. I was like, huh, that's kind of cool.
Yeah. And like you didn't hear, you like we don't really talk about it in engineering when students are going through undergrad. Like you might hear it more in grad school, but like undergraduate, that's not really, that language isn't used too much. And there's a lot of research out there that talks about like there's a lot of problematic implications with not using that language, and it's missing. And so we did a study where like we had 3 different universities. One of them, all we did was change the language. So we kept the exact same course, but we went through the whole course and we said, okay, let's go through it as like experts in modeling and say, where is modeling in this course? And so we went through and we like highlighted everywhere of like, okay, this is like a computational model, this is a mathematical model. And all we did was integrate the language into what was already there. So that was one intervention. And then another one, we took a class where they had design problem, like that whole design process, like solving different design problems in your first year, like hands-on projects. And we took one of the projects and we revamped it. And we said, okay, instead of having the project the way it is, let's make sure to be really explicit about including a CAD modeling component and mathematical modeling development, computational models, and every different type of model, like financial model, like whatever you're going to interact with. And then we had another course where it was like at Embry-Riddle, where we did mathematical modeling, computational modeling as the foundation for the programming course. So like redoing the entire programming course with that foundation. And we did a lot of other stuff. We made a whole like modeling learning community. Basically the most time consuming, extensive thing you could think of around modeling. And then our goal was to see like, okay, what's the difference? What's the impact? And it turns out even just putting in the language was enough to see like that same impact as all the other ones when it came to at least having awareness, which was really cool. We're like, wow, so like literally I can tell another professor, all you have to do is integrate the language and you're going to make the same impact. And when it comes to like awareness of model types as the most like out there crazy course intervention that takes months and months and years of planning.
Wow. Your kind of your ultimate goal is just to familiarize people with these terminologies?
So that's like the foundation. And then yes, like actually going in, and I have some other publications about like different model development process. And I've had a lot more of my publications are related to mathematical models and then some into computational models and simulations, which would be a type of computational model. So then in that area, I look at the development process of like when they're actually building them, and developing them and like what does that look like and all of that.
The computational models is more of like the software stuff.
Yeah, so anything in that software stuff.
Like, what is computational model?
Yeah, I know. So like simulations is one that like people are more like I think aware of and like comfortable with. But the problem with simulations, this is like whatever language specific thing. Simulations in like what it takes to have a simulation requires a visualization component, like the actual true definition of a simulation, versus like if you have a computer program with no visualization component that runs through all your calculations, it's backed by a mathematical model, it's still a computational model. It's just not like a full-blown simulation.
Simulation is more like you want to visualize what you're doing.
Yeah, you got to have some type of visualization for your like outputs and stuff. Yeah.
Well, thanks for sharing that with me.
Total tangent, but now you know more about my research. And maybe you'll integrate modeling more in your courses now. If it comes up, you might be like, hey, we're developing a mathematical model.
Yeah. And people are not familiar with these, you know, like, you guys don't thank me, thank Kelsey.
All right, so back on the PhD, and then the other big title, the PE title. I know you're getting going on that. So I know you've been in this whole journey of studying for your fundamentals exam. You know, I'm curious, like, I want to know more about the foundation of like that big push to get to pass and take that FE, the whole journey of studying it, and then like again that big long-term big picture goal of the PE.
Well, everyone knows that FE, or actually PE, is your ultimate goal as an engineer. You know, getting that PE license is a prestigious number one, and number two, more importantly, is you're being recognized as a professional. So when someone is reviewing your work and you'll look at your title and see PE, they trust you more than someone has no title or EIT, engineer in training, or EI. So the FE is not really what you're looking for, but it's kind of like a small, quick destination that you need to kind of like pass, and then you go to the ultimate destination, which is the P. As a tutor and as a professor, I've been involved heavily on the FE in school. I do a lot of the training and prep courses at University of Colorado Denver and Metro State University for FE. And, I wasn't expecting that I will make a nice big impact on that. So I decided to say, just let's take it gradually and teach people some of the fundamentals. But people, like the way things kind of laid down and outlined the way I want it to be, and came up with an idea, say, why not having a program teach people what is FE, what is PE? And then I started doing that, and people like, why you're not giving us an example of the questions that's going to be on the PE or the FE? So I went with my team, the help of the team, and we created a kind of like a booklet. You can hear me. A booklet with contains and consists of almost 100 questions with a very rigorous and detailed solution. Step by step, telling you where to find it from the manual, the handbook, and why other options are wrong, why the solution that we're selecting is the correct one, what you could do, silly mistakes or minor mistakes that can lead you to select B instead of C. So these things, and we're in the middle of the second version, and actually we're also in the middle of doing something the same with the PE. So the PE is your final destination, so that you need to get in the FE, get it done, pass that 6 hours test, 2.91 or 2 minutes per each question, 110 problems, and then don't feel like the FE is your ultimate goal. I know it's kind of sort of hectic and awkward to say, oh, I need to get another test, but that, I promise, is going to be your last test. Unless you really want to go with the SE, which, obviously you don't really need. So the PE is same philosophy, except the PE has two kind of major components. One is called the breadth and one is called the depth. The breadth is 4 hours test and the depth is 4 hours test as well. The breadth is kind of similar to the FE, and that's why I'm saying focus on the FE heavily, because you could reduce a lot of the nitty-gritty, topics here and there, especially if you're not involved in so many water, resources stuff. Like for example, for me, I'm a structural. When I see transportation and water, I was like, it's been a while. But since I did the FE and I understand what I'm doing for the FE and I'm teaching it, I have easy kind of transition zone to the PE breadth. But then you get into the depth, which I always say, if you get into the breadth, please do, as much as possible practice problems. Get 40 out of 40, because that's going to help you a lot towards the depth. Depth is a whole different animal, especially for the structural. We're talking about 12 manuals, 11 manuals, all these manuals that can ask you anything, with probably just reading one of the statement, and that would be the answer. But then you're going to look at the problems, like what is the minimum, whatever spacing or reinforcement ratios, and you start thinking and pulling all these equations, but it could be one single line in the manual. So it's pretty tricky. That's why do really good on the breadth. It helps you a lot, from my experience with PE and FE. If you do well on the breadth, you're pretty in good shape for the depth. Even if you messed up here and there, you don't need to get 100%. You don't need to get 90. You just need that green, thing with P to pass.
Right. Yeah, it's not about who got the highest score.
Exactly. Yeah, and I keep saying, do not, kill yourself to know every single minor and sub-minor even topic.
Right.
So just, overall, obviously the Legend, we do help with FE and PE, and, it's a matter of fact, it's kind of like one of my strongest suit right now is becoming, because I just, have about 12, 13 clients for FE and 4 or 5 for PE. And then people think that, you know, the PPI or school fee or any other vendors, they're really good vendors and awesome, and they teach what people need. But then that one-to-one relationship at the Legends, what kind of makes us unique. So you start talk to the tutor and you're like, you know, well, I do have a question, send me an email or send me a questions, you know, via text, I will reply. These type of environment, not you don't see all over the places. So
Right.
what makes us unique is more like, come to the session, you'll see the tutor, you ask him why, you know, you don't have to mute yourself and type in the chat box, you know, these type of things. So,
Well, which like transitions perfectly to my next question, which is, please tell us more about like Legend for Tutoring and how it got started. What study help can engineering students get, or even high school students or graduate students, and you know, like what's the team look like, and just how can they contact you? How can they become part of the community that can get help, and what was your big motivation for it?
great question. Well, that's what I really love to talk about.
Good.
So we started the Legend about a year ago. We just made a huge accomplishments in the past year or so. The anniversary for 1 year is going to be actually end of this month.
Woo!
Yeah. And I want to really thank you for being one of the great people, to be honest. I always keep saying that too. Anyone, you know, comes as a fresh tutor or instructor at the Legend and say, I'm going to give you an example. Kelsey Rogers, really, you should be the role model for you. And then really, they kind of like, some people come and say that, well, it's just a side gig, you know, money or something. In fact, tutoring, as you know, Kelsey, is not about only money.
No.
It's about people and how to kind of like help people and draw the smiles on their faces when they understand, oh, that makes sense. You know, these type of things promoted here at the Legend, more than the financial. I mean, nobody doesn't care about money in the financial support, because we need to do better and better, so we need money. But if you're thinking of the money as being the, you know, whole story about the Legend, that's absolutely no. You know, started the Legend by myself as one of the, you know, the tutor slash one of the owners. I do have 4 total owners. You know, I'm the one who's kind of like sort of the tutor, the one who's talking to people, doing interviews. Other, you know, owners, I can't do this without them. And thank you so much, guys. I appreciate you very much, because this can't be done without you and without the tutors that work for the Legend and work with me, because I hate to use for, because that's not my mentality or mindset. We all work for the same institute, same academy, whatever you want to call it, website, company, anything. And then I was not expecting that's going to be that way. So I start, recruiting people and recruiting, some executive assistants, people who can help with invoices, help with these type of visions, and so on and so forth. At this, point, we're being one of the best tutoring companies in the state of Colorado. As a matter of fact, we are in competing nationwide. We've got 103 Google reviews, 5 out of 5 perfect in less than a year. And we actually lost some of the Google reviews due to, Google thought, like, what are you guys doing to accomplish all these, Google reviews? So their like algorithm, they start like deleting some of the Google reviews for us because they thought that we're fake. And I would imagine someone was like 1 year or less than 1 year getting all these, Google reviews, like that can't be, true. That can't be real, But we made it with the help of you guys, obviously with the help of God. It's definitely not my, only work. It's probably I take the least amount of appreciation and least amount of, credit. The credit goes to you guys that, kind of recruiting people. Kelsey joined us about 9 months, 8 months.
Yeah, something around there.
Yeah.
Yeah.
So obviously, was a great ad. I would definitely thank Nika, Elaine, and the crew. We're about right now 60 roughly. Yeah, about 60, including executive assistants, owners, and tutors, and some people help and kind of like provide services, whether tutoring or other services. Uh, Gradually got more Google reviews, published this booklet. I'm very proud to say that we already sold about 12 versions.
Nice. Wow.
That's really awesome for only roughly a month or 6 months.
Wow.
Yeah. What else? We're being nominated one of the best tutoring company here in the state of Colorado. We're going to be on Fox News as well very soon in the near future. I'm being, nominated one of the best CEO owner of, a tutoring company again here. Yes.
That's amazing.
Thanks, Kelsey. Yeah, that's us. What motivates us is kind of like the one-to-one, care about you, care about your child. We don't only drain your money and say see you later once you put in the, sign in the invoice with us. See you later. We're not going to help you unless you need, help from us. We touch base with you. In general, we kind of do what other people do not do. In that context, what I mean by that is more of like behind the scene. People always care about like, oh, we got these and this and that, but we don't really only care about what's being shown, what the client is thinking of us. If I share with you so many messages I got from my clients, thank you for helping my daughter. Thank you for being supportive. I even talk to some of my clients as friends. I don't like to call them clients. They call me, they FaceTime with me. They're like, I'm feeling down. Can you give me a call or something? I love, doing that to my people and to my, clients. And again, this can't be done without the great, amazing, the spectacular, whatever you want to name it, the marvelous team that we have. And obviously, if you want to reach out to us, you could go to www.legendfortutoringdenver.com or call us.
I'll put it in the chat.
Yes.
I'll put it in the description for you too. Yeah.
If you want me to put it in the chat, I will definitely do that.
Oh no, I'm saying I'll put it in the description in the video.
And then you can call us or call the client service department at 720-266-4248, or even you can send an inquiry to us on the website. We would be more than happy to help you and promote whatever you are trying to promote, and get the job done as you want it. So I hope that explains it all.
Yeah, that's awesome. Do you ever hire undergrad or graduate students that are further along in their engineering career, and can they reach out to you for opportunities like that too?
Yeah, that's actually a great comment, because we always are looking for talented and knack tutors. We really don't care about your GPA. We don't really care about, if you got straight A's or if you made a B here or there. We care about your personality. We care, can you explain things to people? We care about, are you reachable? Or, you're gonna have like a hard time, convey the knowledge to people. Do you love tutoring? Do you love teaching people? Because tutoring is not only, we're not talking about money only. We're talking about passion. I started tutoring and I'm still a lot, I've been tutoring for roughly 7 years. Never stopped loving tutoring because it's a passion that I have.
Yeah.
So it's not like, oh, after 2 years, you feel like sick of tutoring and people, then you don't have the passion of teaching. So please reach out to me if you have a passion of teaching. We're always looking for people. At this point, we're looking for a lot of electrical engineering, a lot of mechanical, a lot of part of civil, such as geotech, transportation, water resources, and actually, open so many departments. So you go and check us at the website that Kelsey is going to list. And you're going to see that we teach pretty much everything, K through 12, college levels, professionals, open departments for ESL, other English kind of sort of aspects, certificates, IELTS or whatever other, certificates. We opened recently a PE, geotech, PE, transportation and PE water resources. But please reach out if you're interested. We're trying to get it all. So we're trying to hook you up with the tutor, and you don't have to worry about looking for other tutoring companies. So you'll have it all for you. I have clients working with me for 8-9 months, and I do have people even come, before I was having the Legend, been 3 years with me, 4 years with me when I was doing just on the side, private tutoring.
Yeah.
So
nice. It's funny you said the thing about the intrinsic motivation when we're looping back to the motivation. And now that you're talking about it, I can't help it. Another research thing I do. I've done a lot of research with teaching assistants and looking at engineering teaching assistants and who does well and who gives better feedback and what type of person gives the best kind of feedback. And I remember we were seeing some things with if somebody had the motivation of becoming a teaching assistant because they wanted side money, they were typically ones that did not give good feedback on grading or anything in the classes. But if somebody took that position because they actually wanted to help other people and they cared about their own learning and they cared about the education of others, those were the people who stuck around. They were happier with their job and they gave much better feedback. So
and it's
I think that is an important,
yeah, it's a long-term, goal. So if, as I don't want to keep mentioning that teaching is, it's kind of built-in skill, or you kind of train it to be a natural skill. One of the really thing, that I was always, care, and I still care about it, is when you tutor someone and they go offline, do they feel that you care about them?
Yes.
Or do you want to let's get this 1 hour, get my money, and adios, right? That's that's a lot of people come to us you guys care about us. You guys not just want to tutor us the subject. You guys want to also teach us some of the lessons that we might be interested in, especially for the teenagers. When you teach someone about life, how to be kind of passionate about what you're doing, just be driven and do whatever it needs to complete your homework assignment on time. Do not be a procrastinator. These things, a lot of tutors do not touch on.
Yes.
So
that's wonderful. I think that covers all of my main questions I had. Is there anything else that you would like to share? Any last comments or?
Well, I don't think I have a lot, but I also want to mention thank you, Kelsey, for having me again.
Yeah.
Thank you for being a very energetic and on-to-go person. Keep doing what you're doing. I really appreciate you having, me today, and I appreciate you to be on my team. So that's a win for me.
Yeah. I agree. Thank you so much. And I look forward to having you back on again at some point. We'll have to talk more about motivational stuff. So it'll be fun.
This is my strong suit.
I know.
They can hit me up anytime.
Thank you for watching. If you're interested in Legend for Tutoring or would like to get a hold of Newton, please check out the description. And if you would like to watch more videos with me, please be sure to subscribe to see future videos.